Okay, so this is me going through the Dr. Frost Maths test to help those of you out that did particularly well on it. So I'm going to be doing it on the screen here, and I'll sort of try and type the answers up as best I can. Okay, I've got a calculator in front of me just so you can set the scene. So here we go. Question 1. We've got two similar triangles. And we've got a pair of corresponding lengths, 12 centimeters and 16 centimeters. We've got to get the length QR. You're probably all fine with this question, it's quite straightforward. So the scale factor is 16 divided by 12, okay? And this is 16 divided by 12, 4.3 or 1.3, sorry, 4 over 3, or 1.3333333, okay? Obviously I should write that as 1.3 recurring with a dot over it, and I haven't, but never mind. Right, QR will equal 15 multiplied by 1.33333, okay, and doing that on my calculator I get 20 centimeters. So there's the answer to the first question. Alright, I'm not going to put it on the dots here, I'm just going to leave it there just for the benefit of getting through this quickly. Question 2, similar looking question. Two similar triangles. You've got a pair of corresponding lengths, the 6 and the 15. Okay, so you can work out the scale factor. Okay, now I always work out the scale factor that would take you from the smaller shape to the bigger shape, which is the big length divided by the small length, and I do that pretty much every time, I think. So 15 divided by 6 gives a scale factor of 2.5. Okay, and now I've got to work out the length AC, which is the smaller version of the 20 centimeters. So it's 20 divided by 2.5. Okay, and that's 8 centimeters. So there's the answer to question 2. Alright. 3 marks. This question is a bit tricky. It's sort of a development of the previous 2 questions with a little bit of algebra thrown in. Alright, you've got two similar triangles again. They've got the angles labelled X, Y and Z in both triangles, and we don't really need to worry about that because those two sets of angles are all exactly the same size, 2x's, 2y's, 2z's, and they're in the same places, so that's trying to help us match up the corresponding sides of the shape. I have to say this x here looks a bit bigger than this x here, but of course these shapes aren't drawn to scale. It wants the perimeter of triangle B, and all that's missing is the length of this longest side here. So my ultimate goal is to work out the length of this longest side and add it up with the 4 and the 7 to get the perimeter of triangle B. So I'm going to look over here. Now I can get a scale factor from 10 to 4. Alright, and I'm going to stick with my approach that I mentioned before of always doing the bigger one divided by the smaller one. So 10 divided by 4 is 2.5. Okay, now then, if we look at that 7 centimeters, if you scale that up with the scale factor, you'll get 5W. Alright, so I'm going to scale up 7 centimeters. Okay, I'm going to times it by 2.5 using the scale factor. And I get this number, 17.5. Okay, so this 5W length is the same as 17.5. So that means I can write this equation. Alright, I'm not really thinking too much about my ultimate goal here. I'm just you know, working with the maths that is coming into my head. So 5W must be the same as 17.5. That means I can get W is 3.5. Okay, now that is going to enable me to get 6W. So once I know this length, I can use the scale factor with this length to get this one here. I mean, I could do it with 6W, but that'll be a bit complicated. 6W is 3.5 times by 6, 6 times by 3.5. W is 3.5. Get there in the end. So what is 6 times by 3.5? It is 21. Let's just scroll back up to the diagram a minute. So that length there is 21. So to get this length, I'm going to scale down 21. Alright, so I'll be dividing 21 by the scale factor of 2.5. 21 divided by 2.5 equals 8.4. Okay, so now I've got all the three lengths of this triangle. That's 8.4 there. So I've got to do 8.4 plus 4 plus 7. So I'm going to write perimeter equals 8.4 plus 4 plus 7. Bit of a long question, this one, but as long as you don't panic, it isn't as hard as might first appear, in my opinion. You will probably think otherwise. We've got a unit. Yes, we have got a unit, centimetres. So there's the final answer. Okay. Now let's show you that. There's the questions. There's the answer. In case you want to see it all on the screen, zoom it out a little bit, and there it is all on. Pause this. Want to have a longer look at it. Right, do the next one. Show that these two triangles are mathematically similar. So basically, it says input note, write down the scale factor. Basically, in an exam, you'd have to work out the scale factor from all three pairs of corresponding sides. There's three pairs of corresponding sides. Alright? And I'm going to work out the scale factor using my normal method of dividing a bigger length by the corresponding smaller length. And I'm going to start with the hypotenuse, which is this one 12.5 and this one 5. Two hypotenuses, or hypotenae, or whatever they are. So 12.5 divided by 5. Okay, that's one way of getting the scale factor. What is 12.5 divided by 5? It's 2.5. So that's from the hypotenuses. Okay, and now I'm going to use another pair of sides. So I'm going to call this pair 2 scale factor. I haven't really thought about my working here. I'm doing it on the fly a little bit. So pair 2, this time I'm going to do, of these two, I'm going to do the longer of these two lengths. So that will be 10 centimetres, and over here the longer one would be 4. So 10 and 4 must be a corresponding pair, because they're the longer lengths in the triangles that are not the hypotenuse. So I'm going to do 10 divided by 4, and that's 2.5 as well. So this is going well. I've got the same scale factor twice. If I get the same scale factor this third time, they'll definitely be similar shapes. And here we're left with the smaller of the two right angle sides, 7.5, and the smaller of the two right angle sides is 3. So it's 7.5 divided by 3. Does that give us 2.5? Yes, it does. Okay, and that pretty much proves they are similar. The two triangles are similar. There's a conclusion. As all three scale factors. Now then, that question doesn't work very well on Dr. Frost Maths because I think he just wants you to write in 2.5. So, you know, and just working out 2.5 one way rather than all three ways doesn't really answer the question. But at least you've seen how I've done it now. I'm going to do that thing I did again. Zoom out so you can see the whole of the answer. That's how you do that one. Only 2 marks, but that's a bit mean. Anyway, there we go. Right. Seems to be moving all the stuff down, so I'm just going to move this down. Okay, this is going to scroll off the page. Here is part of a structure for a building. Okay, that's not really that important information. Find the length of BE. Now then, we're going to run into a bit of a problem here because really I want to be able to draw these triangles. So I'm going to have to get a paint package on the screen. There we go. Okay, so I'm just going to do this freehand, so it's not going to look great, I'm afraid. So I can see in that diagram on the left there, I can see actually I can see 3 triangles. Okay, but I think to get the length BE, which is part of the mini triangle at the top, I think I can get that using the triangle at the top. Oh, good lord, look at that. Appalling. Never mind. It'll have to do. So, yeah. Font. A. B. E. So that's the small triangle. A. C. Wish I used a straight line drawer, but never mind. It's too late for that now. So this is 5. And A to C is 5 plus 10, that's 15. Okay, and this length here is 18. So, having drawn that, come back over here. Obviously, I would have drawn this in this space where I'm now writing. So, the scale factor is going to be 15 divided by 5, which is a very lovely 3. Nice scale factor there. And if I've got to get the length BE, that's the 18 scaled down, isn't it? So BE will be 18 divided by 3. And that will be 6 meters. So there's the answer to that first bit. I think this question develops. So look, yep, here it is again, same diagram. This time I've got to get the length DG. Okay, so I'm going to need another one of my lovely triangles. But I'm going to be a bit sneaky here, I think. Yes, I am. I'm going to not use this one. I'm going to use this one that I've already got with the 15 and the 18. Yeah, I'm going to have to draw another big triangle. Brace yourselves. And there it is. It's the best of the lot. With a bit of a wobble at the top. So that's D. A. Clock's gone off again for some reason. And this is G. Okay, what do I know about that triangle? I know AD. If you look at the original diagram, you should be able to see that AD is 25 meters. Okay, and it wants DG there. So I can use these 2 triangles to help me get this. So here's the working. Scale factor is 25 divided by 15. What's 25 divided by 15? It's 1.6 recurring. Now, obviously I'd need to write that the proper way with a dot above the 6 for the sake of time and you know, fiddling around with the computer, we'll leave it like that. DG. Now the length DG, if you come back to these diagrams, DG will be 18 scaled up. Enlarged, if you like. There'll be 18 times 1.6 recurring. Okay, what is 18 times 1.6 recurring? It is 30 meters. Okay, so there's the answer to that question. So it's important you separate the triangles like I've done over here for a question like that. I'm going to leave paint open in case I need to come back to that. Funny feeling I will. And we'll scroll down. Okay, right. These 2 solid shapes are similar. So they're sort of composite cylinders each one. The volume of A is 1,400 centimeters cubed. Work out the volume of B. and I've got two corresponding lengths, so I can get a scale factor. Now, you'll see I've just deleted that there. When you move into 3D shapes and you start talking about volumes and areas, I would start calling the scale factor the linear scale factor, or the length scale factor, I think is what we've been calling it. So the length scale factor or linear scale factor is the 15 there divided by the 12 there. Big one divided by the small one, as always. Oh, I don't know why that's gone over there. Hit tab. Oops. There we go. 15 divided by 12 is 1.25. So that's the length scale factor, but I'm working out a new volume. So I will be using the volume scale factor. In fact, I'm going to write that down. And the volume scale factor is 1.25 cubed. Like that. What is 1.25 cubed? To the power of 3 is... oh, not a very nice looking number, but that doesn't really matter. That number there. So to get the volume of B, you've got to take 1,400, the volume of A, and multiply it by 1.25 cubed. Okay, is this number here I've got on my calculator. I get 2734.375. Now presumably Dr. Frost wanted me to round that up, so you would have to round it up in Dr. Frost Maths. Okay, I'm just going to check it again. Yeah, I have got the right thing. So there we go, there's the answer. Like I say, you might have to round it to one decimal place, but the important thing is how we've got there. Sorry, I'll just scroll back up. So if you need to pause and have a look at my working for that question, there it is all on the screen. I'm going to move down now. So here's another question. The diagram shows two pieces of glass. They're obviously for church windows or something, looking at that shape. The pieces are similar. The area of the small piece is 6,000 centimeters squared. Glass costs £80 per square meter. Work out the cost of the large piece. So if it's 80 quid a square meter, we're going to need the area of the large piece. Okay, so this is going to be about area scale factor. We can get a length scale factor using those two lengths that the question has given us. So that's 75 divided by 50. Okay, the length scale factor is, I can see it's 1.5, isn't it? Keep on checking this on a calculator. There we go. So there's the length scale factor. The area scale factor, which is what we'll be using in a similar shapes question that mentions area, is 1.5 squared. Okay, 1.5 squared is 2.25. Okay. Okay, so I can use the area scale factor to scale up the smaller area, which is 6,000, to give me a bigger area. So big area equals 6,000 times by 2.2 times by 2.25. (13,500 centimeters squared). Okay, now then, it's £80 per square meter. So I've got to turn this into square meters. Okay, or I could do this. I could say, well, if it's £80 for 1 square meter, let's work out how many square centimeters there are in a meter. It's not 100. Okay, so it's not £80 per 100 centimeters squared, unfortunately. You've got to think about this. We've spoken about this in class before. 1 square meter is a picture a square that is 1 meter by 1 meter. Okay, just picture that square. If it's 1 meter down the side and 1 meter along the top, it's also 100 centimeters down the side. That's a meter, and 100 centimeters along the top. So picture that square with 100 centimeters down the side and 100 centimeters along the top. To get that square's area, you would multiply 100 by 100, which is 10,000. So it's £80 for every 10,000 centimeters squared. Okay, so what I'm going to do to work out the cost of the window is take 13,500, divide it by 10,000 to see how many square meters there are. Okay, let's do that first. And it gives me 1.35 square meters, or meters squared. Okay. Well, no, sorry, it just gives me 1.35. There's 1.35 of those, so it's 1.35 times 80. 80 times 1.3. So it's £108. Okay. How well this is going to work with the zooming, because it's going to go all tiny, isn't it? Quite worked, I'm afraid, boys. Okay, there's the original question. In 75. There's the words of my working. Okay, let's move on. The diagram shows two mathematically similar vases, A and B. A has a volume of 405 centimeters cubed. B has a volume of 960 centimeters cubed. B has a surface area of 928. Work out the surface area of A. Now, to some people, this will be the hardest question of the test. Okay, they're giving us two volumes, so we're going to be able to work out a volume scale factor by dividing the big volume by the small volume. So I'm going to do that now. 960 divided by 405. Okay, I get this number that says 2.370 dot dot dot. Okay, it's a load of recurring stuff. Now then, I've got to do something with area. And what this question is testing is that you all understand that the area scale factor is the square of the length scale factor, and the volume scale factor is the cube of the length scale factor. So what I'm going to do now is cube root this volume scale factor to get the length scale factor. So cubed, I'm just typing it, just easier this way. Not quick enough to do the editing. So the cube root. So I'm going to cube root answer on my calculator. Okay, cube root answer. And I get, oh, that's better. I get a nice 1.3 recurring type answer. Now we're trying to deal with areas, so I'm going to scale that up. The area scale factor is the length scale factor squared, isn't it? So it's 1.3 recurring squared. 1.3 recurring times 1.3 recurring. So I'm going to do answer squared on my calculator, and it gives me 1.7 recurring. Anyway, I've now got an area scale factor which works with surface areas just as well as it does with areas. Going back up to the question has told me B, which is the bigger one, has a surface area of 928, and I've got to get the surface area of the smaller one. Smaller, remember it's smaller. So to get the surface area of A, it's going to be 928 divided by the scale factor of 1.7 recurring. So on my calculator, because it's still got it on there, I can make use of the answer function. I get exactly 522. And because it's so exact, you know, I'm confident I've got this right. So that is the answer there. Okay. Oh, sorry. I'll let you see what I've done. There's the question. My first bit of working. Okay, I mean this question's centered around all of this. The fact that you've had to go from a volume scale factor back down to a length scale factor, and then back up to an area scale factor. And they love those questions. GCSE exams, they're really common questions, higher tier. Alright, so you need to be able to. Right, now we move on to some congruence. Prove that triangle ABC is congruent to triangle ACD using ASA, angle, side, angle. Okay, well, the interesting thing about that is we don't know any side lengths. So it's very difficult to say this side in this triangle is the same as that side in that triangle. But both triangles share length AC. So you know that the length AC in both triangles is the same because they're touching each other. So that's the S part of ASA sorted. Okay, because they both share the length AC. They both share that same side. Side is the S bit of ASA. I've got to show that they have the same angle either end of that length. So I've got to show that whatever this number is here and 56 is the same as whatever number we've got here and this number here. So I need to work out these two missing angles using angles in a triangle. So I'm going to work out angle ACB first. Angle ACB, so I'm focusing on the top triangle. Okay, this one here is 180 minus 80 minus 56. I already know what it is, and some of you might have twigged what it is. It's 44. So that there is 44. Now, hopefully you can already see what's going to happen when I do the same calculation here. I'm going to get 56. So we'll have 56 AC as the side between it and 44. So we'll have a side of AC sandwiched between 56 degrees and 44 degrees on both triangles. Okay, and just to be absolutely clear, even though you might think it's obvious, I'm going to write down calculation for the missing angle in the bottom triangle. I'm not going to type it into my calculator because I know it's 56. So the conclusion here is this angle. I'm struggling to see them. Okay, angle BAC equals angle. So that's the 56 degrees in the top triangle equals angle DCA in the bottom triangle. Angle BCA in the top triangle, that's this one here that we can still just about see, and that's 44, remember, is the same as that 44, so that's equal to angle DAC. So they're the same, and length AC, I've just noticed there's analogy. Length AC equals length AC. It's a bit of a pointless thing to write. Congruent by ASA. Okay, I've got that. There we go. So that's how you answer that question. I'm not quite sure how you do that on Dr. Frost. You've presumably got to choose a multi-choice answer, but it will be based on the work I've just done there. Okay. See if we can scroll it out so you can see it all again. I like it on the page. Have it then. One more. Well, okay, you've got all the rest of it. See it all. Yes, you can see it all. It's just a bit offset there. Okay, so you can pause it if you want to have a longer look. Okay. State whether the two triangles are congruent or not. If they are congruent, state a reason from these. If they're not congruent, write N for reason. Well, they've both got 12 centimeters and 16 centimeters, sandwiching a 50 degrees between them. So they've both got the same pair of sides, that's two S's, two sides, and an angle sandwiched between them. So the answer to this is yes, they are congruent, and SAS is the rule. Side, angle, side. Side, angle, side. Okay? quick, easy, easy. Okay, we've got another one now. In this one, you've got 60 degrees, 60 degrees, and 12 and 16. Now this is a bit of a weird one. If these two are 60 degrees, what's this one here, this missing one? Well, that's also 60 degrees. So these are actually both equilateral triangles. Okay, equilateral triangles. I know they don't look like it, but it does say it's drawn to scale. And they can't be congruent, because if this is an equilateral triangle and you've got 12 here, they're all 12. So all the sides here are 12. Similarly, all the sides here are 16. So they are not congruent triangles. Both different sized equilateral triangles. All angles are 60. Okay, so that's a quick one as well. Oh, here we go, there's another one. Are these the same? Well, yes they are, because they're both right angled triangles. RHS is right angle, hypotenuse and side. These are two right angled triangles, so that's the R bit of RHS. They've got the same hypotenuse, the H bit of RHS, and they've got the same 12. So the S bit, so they're congruent, and the reason is RHS. Proper job. That's the end of the quiz, test, whatever you want to call it. That's it. I'm just going to scroll up again.